everyone. Today is going to be our, I think, our fourth physics lesson. So most of you guys remember last time we talked about an intro to kinematics. So we talked about scalars and vectors. We also talked about speed versus velocity, velocity versus acceleration, distance and displacement, and how to calculate average velocity, average speed, and a lot of the conceptual things involved with that. So I know that there were some kids, especially younger ones, who might be confused because this is very much a new topic for many students. So today we've dedicated this lesson to kind of go over a lot of those topics, do a lot of practice questions, and try to get your guys' input and you guys to try to get to answer some questions so we can get like our minds actually thinking instead of just a straightforward lecture. So we're going to start off first. We have, I think, a new instructor. So yeah, Vishnesh, you want to introduce yourself real quick?
Yeah. Hey guys, I'm Vishnesh. I'm doing the 12th grade right now and I'm from India. So tell me if you have a problem understanding my accent or if you want me to say stuff again. But hey guys.
Yeah, so if you ever like need something repeated or just ask Vishnesh to repeat it again, or you can try to type in the chat as well. It's totally okay. So yeah, welcome Vishnesh. Again, we have other instructors, Rimjhim and Lily, which are returning people, and we're gonna go right ahead and get started. So first, we're gonna review distance and displacement because that is something I think some kids were definitely confused about. I'm going to go ahead and go through a worksheet with each of you guys and ask for your answers on that. So I didn't share this worksheet. Oh, sorry, this is the wrong one. Chrome tab. Yeah, okay, so is everyone able to see my screen here? I'm sharing like a worksheet. Oh, someone's still joining. Okay. Type in the chat if you're able to see my screen. Okay, so that's good. So I'm going to be writing on this PDF throughout this lesson. So we're essentially going to do a review of what we talked about last time. And if you guys aren't sure of anything, we're going to pretty much explain it again. So let's start with like the first question. So vectors and scalars, that's something essential in physics. I think if you want to go ahead and go through this. Yeah.
Okay, I'm actually going to start with number 2 and 3 first because it just makes a bit more sense to me. So everyone can just type in the chat, try to answer the question. So number 2, the question is, a quantity that is ignorant of direction is referred to as a, type A or B, or that works too. Good job.
Okay, so it seems like we want to get we want to get at least 5 answers for each question if possible. So I'm going to go ahead and circle that. The correct answer is that a quantity that is ignorant of direction, which means it doesn't have a specific convention assigned to it. It's just a magnitude itself, is a scalar quantity. So, okay, despicable me. Okay, and yeah, sorry, keep going.
Now, number 3. If you got that one right, you can probably guess this one pretty easily.
Okay, so someone asked, what are scalars and vectors? So scalars and vectors, you can see actually right here, a vector is a quantity that is fully described by both magnitude and direction. So it's essentially, magnitude is something that has units, it's something that has a value. So magnitude is sometimes just a number, but a vector itself also has a direction. So let's say that our speed, it's kind of giving an example, our speed is 10 meters per second. And then our vector, our velocity, is equal to 10 meters per second again, west. So that you see the difference here. 10 meters per second is just a magnitude being a value. And then a vector actually has a direction. So we're going 10 meters per second west. So typically vectors, they have a direction. Maybe we're going north, maybe we're going south, east or west. Maybe we're going in the left direction, we're going in the right direction. So that's essentially what that stands for. Does that make sense to everyone? Yeah, okay, that's good. Yeah, so now that we've, so I kind of gave away some of the answers, but Lily, if you want to keep going.
All right, and then so now we're just gonna classify them. So displacement, is displacement a scalar or a vector? Yay. Good job, Michael. Good job, Hans. All right, so because it has a direction, you're gonna say like 10 meters and then west, right?
You were displaced by 10 meters. So if you don't remember what displacement is, it's like your straight line. Regardless, I have an analogy I always give. It's like if you were hiking in a mountain and you took like this really unnecessary long, like squiggly path when there was actually like an easier way to get just from point A to point B. So your displacement would be like, even though you walk maybe for like 3 days, you walk like 100 miles through this like wavy, curvy path. You actually, technically, from your starting position to end position, you only moved maybe like 50 miles. So that's like an analogy I use a lot. So yeah, let's keep going.
All right, and then distance is what? Scalar. Good job.
Also, we want to get at least like 3 answers before we release.
Yeah.
So let's keep going. Yeah.
And then speed.
Okay. Yeah. So you guys seem to understand. Speed is a scalar. Speed only refers to the magnitude of our change in position over time.
And then velocity. Who can tell me that? Cool.
Okay, so we got a lot of.
I feel like we only have 3 people.
Yeah, if you've never typed in the chat, please do. Don't be scared.
And should I try to call on someone? Wouldn't that be fun?
Yeah, that'd be. Yeah, what if we went? I don't know. Maybe we just keep like with kids responding in there. Okay, and then the last one.
And then acceleration.
Okay, so we have a couple. That is correct. Acceleration is a vector because since velocity is a vector and acceleration describes our change of velocity, acceleration kind of has to be a vector. Yeah. So yeah. Also going to circle that it's conscious direction. That's a vector quantity. All right, so let's keep moving on. Yeah, let's keep going. So now that we've gone over distance and displacement with regards to scalars and vectors, we're going to talk about distance versus displacement specifically. So yeah, Lily, if you want to keep going.
Yeah. So number 4 is a true or false. An object can be moving for 10 seconds and still have 0 displacement. Is that true or false?
Let's get a consensus here. You gotta think about this one. It's kind of a trick question.
Good amount.
Okay,
and
so
number 5, why is it true?
I want you guys to like give a specific example where this would be true.
Yeah.
Yeah, so like maybe give a real life example. Yeah, so.
Good job. We are very smart people.
Okay, so it seems like everyone has a really good idea of this. Everyone still remembers that really good example that we talked about last time. So yeah, imagine that I'm a little jogger. I'm running it. Okay, I'm running in a circle. Yeah. I run in this big oval track for 10 seconds. From my start to finish line. What is my straight line path from my start to finish? Well, I didn't change at all, right? I literally went from start to finish. I traveled all this distance, but I ended up where I began. So this is an example of where an object is moving. My position changes in this 10 seconds, right? Because I was located here and then I go here, so my position definitely changes, but I have no displacement, even though I ran for those 10 seconds. So yeah, you guys all understand that, which is really good. So let's keep going.
Okay, suppose you run along 3 different paths from location A to location B. Along which paths would your distance traveled be different from your displacement? Ooh,
I'm really glad people are understanding this.
yeah.
You can just look at circles and trace the edges with your eyes. Yeah, that's true. Your eye has motion, but it's kind of like rotational too. Yeah. Okay.
So then, good job. Straight line distance from A to B, and then 1 and 3 are going out of that straight line and thus having a greater distance. All right, Cleo.
The displacement from A to B is just a straight line, but it's kind of like that analogy I talked about with a winding path. You took this really difficult path, but your total distance from A to B or displacement was this straight line. So yeah, we're gonna keep moving on. But guys, if you ever have any questions, make sure to state them in the chat. So yeah, now we are on the second page. So now we're actually gonna do a little bit of calculations. So yeah.
Oof. So you run from your house to your friend's house. That is 3 miles away. Then you walk home. So what distance did you travel? And what displacement for the entire trip?
Oh, okay. We're gonna get some answers, and then I'm gonna answer Athena's question. So yeah. I am first. Yeah, good job. Okay, yeah, so yeah, good job to Hans and Alice. The answer for A, you traveled a distance of 6 miles. You went like 3 miles forward and 3 miles backward. So you travel 3 miles and you travel another. That's a total of 6. And always write your units. So I'm writing 6 miles. What about your displacement? You guys also have the good idea. Once you guys kind of intuitive, yeah, definitely. But a lot, again, for a lot of students, this is really confusing, I think. A lot of my students in my class are struggling with this in high school. So displacement is going to be 0 because your start is here. You go all the way here, you come back. You finish at the same place. There's no change in your actual start and final position. So your displacement is 0 miles. Okay, Athena, if you want to ask your questions right now, go ahead. Yeah, for that other question. What's wrong with the straight line? Okay, let's go out to that page. Okay, so it's asking you, which path would your distance be different from your displacement? Are you talking about this question here? So what's wrong with this? Well, there's nothing really wrong with the straight line. It's just that this one actually shows the displacement from point A to point B. This one, we have the actual path taken, but it doesn't show our displacement. So our distance is different. Our distance is actually a bit longer. We walked a little bit here, and then we walked here. We could have just taken the straight line. So our displacement is not the same. Same thing here. The straight line from A to B is our displacement, but our distance is actually this path that we took. Does that make sense? 1 and 2 are the same length. No. So like, actually, I should erase that if possible. I don't think I can erase on this strange thing. But essentially, no, like path 1 is a bit longer. I'm gonna actually draw this. If you go here, let's say that this is A and this is B. And then for the same A and B, you just go there instead of taking this. Which one is longer, 1 or 2? Yeah, so 1 is longer. So 1's distance is longer, but their displacement is the same. Ultimately, they have the same straight line distance. Like a person could have just taken the straight line path. So their distance, the path that they actually took, is their distance. Displacement is a straight line change in their position. Does that make sense, Athena? Okay, that's good. We're gonna keep moving on. So go back to that second page. So now we have a couple more questions left. Lily, if you want to keep going, sorry.
Yeah, so this one's going to take a little more time, but you're going to basically find the distance of the path from A to B, of the path, and 1 kilometer is like one little dash, right?
Edge.
So you don't have to count them.
1, 2, 3, kind of.
Yeah.
So I want you guys to try to figure out 8 and 9. What is their distance and what is their displacement? Just a lot of counting little squares. Also, I plan to do a Kahoot if we had time, but I think if we spend all our time going through this in the next worksheet, I think that's more important than the Kahoot. I'll actually send the Kahoot as a challenge for you guys to do. My computer just restarted in the middle of a question.
Sucks.
That's okay. I'm recording this so you can watch this later, but I don't think you missed. I think I just went back to another question and explained it again. So, Hans, you're totally chill. Yeah, you're good. All right. Do you have some answers for 8 and 9? Go ahead and type it whenever you feel free. Okay, so Lily, if you want to reveal the answer.
For those who got 31 kilometers, that's correct, because there's just 31 little squares that we have to count. It's fine. You know, it's probably hard to see, so it's not that big of a deal if you get it wrong. It is like a perimeter. And then for the displacement question, we're counting the straight line distance from A to B, and that really, the shortest path is three little lines, so that's 3 kilometers. But since it's displacement, you also need a direction. And since you're traveling westwards, or eastwards, sorry, it's going to be 3 kilometers east.
Remember that displacement needs to have a direction. So it's not just 3 kilometers. You have to say also what direction it's going in, since it is a vector. It's conscious of that direction. So it is going in that east direction. Does that make sense to everyone, this question?
There's like a little compass in the corner if you couldn't see. I'm hungry.
Okay, cool. I think this is the last question. This one might be a little bit confusing, so make sure you like carefully go through it. Yeah.
So basically, when we're gonna find the distance, you go from A to B to C to D, and then you gotta add.
At each point, it's for example, at T, after 1 minute, the skier has moved from A to B. Then after 2 minutes, after another minute has passed, the skier has moved to C. And then after another minute, total of 3 minutes, the skier has moved to D. And T stands for how much time has passed since their beginning position A. So let's try first to A and B. What is the distance traveled by the skier in that total of 3 minutes? And what is the net displacement of the skier during the 3 minutes?
Let's double check our math.
Yeah, be really careful. And look at where the skier is going at each point. It's kind of like woo, woo, woo. Net. Okay, so when you think net is kind of like if they traveled, for example, net is just like displacement. So if you walked forward 10 meters and you walked backward 10 meters, your net displacement is 0. So yeah. Remember that also displacement has a direction. So I think we have a lot of answers already. So I'm just going to go ahead and reveal A. So A is going to be total distance. So it's literally the entire path by the skier. So we can actually like draw this out, even though it goes back and forth. The skier first moves 160. Then it moves another length of 160 minus 40. So the distance between the first minute and second minute is going to be 120 meters. Then from 2 minutes to 3 minutes, the difference between 40 and 120. Remember, this is actually like kind of like a measuring scale, an indication of their position from their origin. So that's 80. So now we have gone 80 meters. So when you add that all together, that's 360. So the distance traveled is 360 meters. Net displacement, however, the skier only travels 3 minutes. So our displacement is going to be our straight line distance, or our net change in position from start to finish, regardless of the actual path they took. So regardless of the fact that he went back and forth, right? He only went from A to D. He started at A and he ended at D. So our net displacement magnitude, first of all, is 120 meters. And our direction, remember, displacement needs a direction because it is a vector. Our direction is east. Or you can just write E. And then, how come 1 minute is faster than
it doesn't matter, like there's
no?
It's just saying like, oh, by that minute he's there.
Yeah. Because right, like, because actually remember velocity, or his average velocity would just be this divided by 3 minutes, or how many seconds. So the displacement during the second minute, from 1 to 2 minutes, our displacement is going from 160, the position of 160 to position of 40. So that's a difference of 120 meters there. So yeah, our displacement from the first minute to the second minute is 120 meters. And now what direction did he change from 1 to 2? He went in the west direction. So we need to have a direction on that displacement. Finally, the displacement during the third minute. So from 2 minutes to 3 minutes, our difference is going from position 40 away from 0 to position 120 away from 0. So he went 80 meters and he went east. That concludes this worksheet. So does anyone have any questions about this distance versus displacement? I think that like cleared up everyone's confusions about it. So yeah. Type yes if you're ready to move on to the next one. Yes. Okay, cool. That's awesome.
All right, I'm gonna go.
Yeah. Say bye to Lily.
Bye, guys. Continue learning. Have a good time. Adios.
And we're gonna continue on with so Lily is gone. Now we're gonna continue and move on to our, I think, second worksheet. So I'm gonna change my screen. Second worksheet. So now we're gonna talk about the conceptual applications of speed and velocity. So I've done enough talking. I think I'm gonna let Rimjhim and Vishnesh kind of like alternate for this one. So yeah, let's go ahead and start.
Could you zoom in just a little bit more?
Yeah, I can zoom in more.
Yeah. Okay, thanks. So first work, or okay.
1 second. I'm gonna it won't let me get rid of the side.
It's fine. I think I can see it pretty well. Just have to look a little bit closer. Okay. So a blank quantity is completely described by magnitude alone. A blank quantity is completely described by a magnitude with a direction. Yeah, we went over this in our last worksheet.
Yeah, so I think that's a quick answer.
Yeah. Okay, I think I'll do the second question too. So speed is a blank quantity and velocity is a blank quantity. Yes. Can we get more answers?
That's good. You guys all got that one right.
Okay.
I think Vishnesh is going to take over the second section now.
Yeah. Okay. So suppose you're considering 3 different paths A, B, and C between the same 2 locations. Along which path would you have to move the greatest speed to arrive at the destination in the same amount of time? So the first thing you notice is that the amount of time is the same, and they're asking you about the speed, and we know speed is distance by time. So the key to this question is basically finding out which one has the most distance. So in A, you see that it's the shortest path. It's just a straight line, path A. So that would be the least distance. Path B would be the second largest distance, and path C the largest distance, because obviously there are like a lot of zigzags, so you travel more distance. So because speed is distance by time, that means path C would have the greatest speed, followed by path B, followed by path A. You all get that? You understand why you need a greater speed? Because there's more distance, so you should be going faster if you want to cover that much in the same time. Yeah, I think you can do the 4th and 5th because they're both kind of related.
Yeah, so essentially, it's saying that let's actually say that like a little person is starting at path A and then another person at B and C, and they're like racing, and they all tie at the same time. So they finish this path at the same time. So which person has to move the fastest? A, B, or C to get to the same destination? You guys can go ahead and type in the chat. If they all tied and running these 3 paths, which path would the person have to run really fast to catch up with the other 2? Maybe my chat is lagging. Yeah, so we got 3 answers already. So yeah, as Vishnesh said, speed is dependent on distance divided by time, right? So ultimately, they would have to have the greatest speed in path C to keep up with the other 2 people. So yes, that's correct. I'm going to keep going on. Yeah, Vishnesh, you want to keep going for 4 and 5?
Yeah, sure. So 4, is it possible for an object to move for 10 seconds at a high speed and end up with an average velocity of 0? So true or false? What do you guys say?
Yeah. True. Like a couple more answers. Yeah.
Yeah. Okay. Cool. So it's kind of similar to what we did in the previous worksheet. So we know that average velocity is displacement by time. So if displacement is 0, average velocity is going to be 0. So if oh wait, so that's the 5th question. So if it is true, think of an example where this is possibly true.
It's really similar to that first, because remember, velocity is not the same as speed. Velocity is, I'm actually going to type my text here, displacement divided by, oh my gosh, time. So if it has an average velocity of 0, its displacement needs to be 0. So can you give me an example where a displacement is 0? Essentially. That's really hard to think. It's really hard to understand for a lot of kids. How can average velocity be 0? You know, because velocity is just, sometimes in your life, it's just like an interchangeable word for speed, right? So can you guys give me an example where your average velocity would be 0 even if you moved at 10 seconds? Why are people leaving the meeting? It's okay.
I think people are just getting disconnected from the meeting. So
yeah. So essentially, like an example of this happening is like, remember that we had that oval running track with some little person running. They ran for 10 seconds around this entire track. But what is their displacement? Since they end up the same path, their displacement is literally 0. So it doesn't matter how long they take to run, 10, 30, 50 seconds. Their total velocity is going to be 0 meters per second. Does that make sense, everyone, why you can run all this like distance and still have a 0 velocity? That's like a kind of a counterintuitive and weird concept. Okay, so we're gonna keep moving on. So Rimjhim, if you want to take over now for 6. Oh, can you guys hear me? Hello?
Yeah, I can hear you.
Okay, sorry.
Wait, I disconnected really quickly. Did you ask me to explain number 6?
Yeah, so we're moving on to number 6 now, yeah.
Okay, cool. Suppose that you run for 10 seconds along 3 different paths. Rank the 3 paths from the lowest average speed to the greatest average speed.
So you run for the same time for all of them. Remember, I'm actually going to type the differences between speed equals distance over time. And then velocity equals, oh, that's a bad spelling, displacement over time. So let's get like for the first one, second one.
Or should I start explaining?
Yeah, you can go ahead and start explaining.
Okay. So as Meryl said, speed is equal to distance divided by time. So we need to think about what path has the greatest distance, since the time taken for all the paths is the same. So if you look at it, path A has the greatest distance. So it has the greatest average speed. I guess I'm going backwards here. But yeah, greatest average speed. So it's number 3. And then path C has the second greatest average speed. And then path B has the lowest average speed.
Does that make sense, everyone? And we can go ahead and explain the second question.
Okay, so I think this is kind of like hold on. Where's the sec?
It's like rank.
Okay, cool. All right. So hold on. Path A. Okay. So displacement is hold on. Okay. So velocity is equal to displacement divided by time. Once again, they have the same, or they took the same amount of time. But if you look at path A, the displacement would be 0 because it comes back to the same place, or at least from what I can see, it's 0, right? And for path B and C, they look about the same. So path B and C would have the same average velocity, and path B and C would have the same average velocity, and path A would have the lowest average velocity. Yeah, what Meryl wrote.
Does that make sense, everyone? Type a yes and it does. Yeah, that was a little kind of tricky one. Path A had 0, but path B and C were the same. So I think we're gonna keep moving. We probably won't have time for Kahoot. Oh well, it's gonna be an individual challenge probably. So yeah. So yeah, we're gonna talk about now for calculating actual average speed and average velocity. So it's kind of like building on our understanding of displacement versus this distance. So I'm gonna keep those formulas up there. If you guys want to have a try at number 7. You run from your house to a friend's house that is 3 miles away in 30 minutes. You then immediately walk home, taking 1 hour on your return trip. What is your average speed and average velocity? Keep in mind, however, I want you to report this in miles per hour, and that's in minutes. So keep in mind about that. Units is important. Someone is crying. Why are you making a crying emoji? Remember, it's in miles per hour, and this is given in 30 minutes. Well, this is given. And then displacement is different. Velocity is dependent on displacement. Okay, so we can go ahead and reveal the answers. So I'm just going to go ahead and say this. So the average speed is distance over time, and we want it in miles per hour. So the total distance traveled, if they traveled 3 to the friend's house and then 3 miles back, that's a total of 6 miles. And what's their time? So they took 30 minutes. So 30 minutes is like half an hour, right? So that's 0.5 hours. We can convert that. That's a terrible H. And then they took 1 hour the return trip. So their total time is 1.5 hours. So if you just do 6.5 divided by 1.5 really quickly, that's going to be equal to 4 miles per hour. And velocity, okay, well, velocity is displacement over time. You guys, a lot of you guys are correct. Displacement is literally 0 because going back and forth, your position ultimately didn't change. So it doesn't matter what it's going to be 0 miles on the top. It doesn't really even matter. We know that we travel 1.5 minutes, but anything 0 divided by anything is 0. So we know our average velocity is going to be 0 miles per hour. In this case, we don't have a direction because we didn't change. Yeah, so I think this is our no, we have one more page. Okay, so this is our final question for this one. So Vishnesh, you want to take over this question for now?
Yeah, so a cross-country skier moves from location A to location B, to location C to location D. Each leg of the back and forth motion takes 1 minute to complete. The total time is 3 minutes. The unit of length is meters. Calculate the average speed in meters per minute and the average velocity in meters per minute of the skier during 3 minutes of recreation. So the thing we need to find here is average speed. And if you remember from what was on top of this sheet, average speed and average velocity, but average speed is total distance by total time. And you know that total time is 3 minutes, which is given in the question. So you calculate distance the same way you did in the previous question. So from A to B travels 116. Do you guys want time to do this? Or?
Yeah, let's give us some time to try to solve for average speed and average velocity for that 3 minutes of skiing. And pay attention to the units. It wants meters per minute. So everything's kind of already set. It's given 3 minutes, and also the bottom position is in meters. So let's give some time.
Also remember that one of them is a vector and one of them is a scalar. So think about what else you would probably have to mention in your answer.
Yeah. I think we're just going to have 1 more minute for you guys to try to solve this one. Pay attention though. Look at the way the skier is going back and forth. That's what the positions A, B, C, and D represent. So be careful not to make any like simple errors with like adding and subtracting here. Okay, so Vishnesh, you want to go ahead and reveal the answers?
Yeah, so I think so Michael said 4 minutes, but so I'm not completely sure how you got that, but I think a key pointer in this question at least is that in the question they've given you the total time. So when you have things like that in the question, it's just probably better to go with that. But if you do want to calculate like how much time it actually takes, you can see that from A to B it's 1 minute, from B to C another minute, and then from C to D another. So it's only actually 3 minutes, which is the total time. So once you figure out total time, the next thing you need to find out is total distance. So first he moves from A to B, which is 160 minus 0, which is 160 meter. Then from B to C, which is 160 minus 40, which is 120 meter. So, and then the final length he travels is from C to D, which is 120 minus 40, which is 80 meter. So, yeah, so this is totally 360 meter. And you know that speed is distance by time. So that would be 360 by 3, which is 120 meters per minute.
Yeah, so our speed is our total distance over our total time. That's minutes and that's meters. Where are my units? So it's going to be 120 meters per minute. And I saw some varying answers for average velocities. So Vishnesh, you want to go over that real quick?
Yeah, so in terms of time, it's still the same because he still travels for the same time. So we just need to find displacement. So we can see that the final position is at D, which is 120 meters away from A. So the magnitude of the displacement, or the value of the displacement at least, is 120. The next thing you look at is the direction. So D is to the east of A. So we say that the direction of displacement is east. So the velocity would be displacement by time, which is 40 meters per minute in the east direction. It's important that you mention the direction because velocity is a vector.
Does
Also,
that make oh, sorry, what?
No, I just wanted to say that if you guys don't understand any of this, please do tell us. Don't just assume that speed and velocity are kind of simple and you can figure it out later, because a lot of this is actually used in the physics you'll do later, and it's kind of important that you understand all of this properly.
Yeah, this carries over to forces. It carries over to pretty much every topic involved.
Yeah.
So yeah. Yay! So good job to everyone got that right. If you got 0, just be real. This one wasn't a trick question. There actually is a displacement here. We're going from A to D, so our ultimate change in position is 120 meters east. Okay, yeah, it's in minutes. You always want to pay attention, even though our usual, if it's not given, we always write in meters per second. You really want to pay attention. Here it's literally telling us they want us meters per minute. They really want us to give us in this units. So if you didn't give it in the right units, or I think I also noticed some students, if you don't write units, sometimes teachers were like, they're really stingy. They might like mark up points. So get used to writing units always. I think I make a big deal about that when I take tests. I like circle my answer for the units so I don't get any points off. Okay, so I think that's it for this page. We're gonna keep moving on. So now we have some like kind of critical thinking problems. We're gonna skip this page because we did not talk about instantaneous speed, and actually that's a calculus concept that I don't think you understand. So yeah. Let's go over some of these questions. So let's try number 11. I'm going to read the question to you guys. You have a couple of minutes. We have 10 minutes left. Police would check a highway for speeders by sending a helicopter in the air and noticing the time it would take for the car to travel between 2 wide lines, placed 1/10 of a mile apart. On one occasion, a car was observed to take 7.2 seconds to travel this distance. So how much time did it take the car to travel this distance in hours? So if it, let's draw a photo. I'm going to draw it out here. So 2 wide lines. It's actually this actually involves like some lab techniques of how to measure. So the car, we have a little car. Sorry, really bad drawing. And the police are looking at how long it takes this car to travel 0.1 miles. So if it takes a car to travel 7.2 seconds in to travel this distance, how much time is out? And convert, we want to convert 7.2 to hours. So let's see if you guys can do that. So just try to think about the relationship between seconds, minutes, and hours. This, you can actually use that metric conversions technique with drawing out that cross table, or dimensional analysis, actually what it's called. So if there's 60 seconds, 7.2 seconds, and there's 60 seconds in a minute, and there's 60 minutes in a second, you can actually determine how many, we just want to convert 7.2 seconds to hours. So let's see if anyone can do that. So we have one answer for, I think, part A. Let's try to get a couple more. We don't even really care about the 0.1. We just want to know how much 7.2 is. So I'm actually going to do a dimensional analysis to teach you guys. I think you guys might be a little bit confused. So this is pretty similar to how we converted metric when we talked about, like, 3 weeks ago. We were converting like kilometers to meters. So we start with 7.2 seconds, and we just have an arbitrary unit 1. We want to cancel seconds. So now we're going to convert to minutes. And we want to put seconds at the bottom to get rid of that unit. So in 1 minute, how many seconds are there? 60. So we're canceling this units of seconds. So now we have like 72 divided by 60 minutes. Now we want to, our ultimate final unit is hours. So we want to get rid of that minute. So we're going to put minute on the bottom again and hour on top. So in 1 hour, how many minutes are there? There's 60. So now we can just multiply the top and then divide by whatever's on the bottom. So we can do 7.2 divided by 60 divided by 60. It takes this car 0.002 hours to travel 0.1 meters, miles, sorry. Alas, yeah, 1/500. So what is the speed of the car in miles per hour? So now that we know their time that we want the units to be, can we calculate speed? And I'm going to type, remember that speed equals distance. And this part should be easy for you guys because we know what, yeah. You want to pay attention. Speed is distance over time. So you want to divide distance by time, not the other way around. Just be mindful of that. Yeah. So it's going to be miles per hour, not hours per mile. Yeah. So just flip-flop that fraction. It should be good. And let's try to get some answers. I've seen the same 2 people. Can we get some different answers from all the 13 people, 12 people in this chat, in this lesson right now? Yo, that's a big number. Something's off. Okay, so I'm going to reveal the answer. So this one's pretty simple, right? We know distance and we know time. So we know it's 0.1 miles. and we know that we have 0.002 hours. So we just divide that real quick. 0.1 divided by 0.002, that gives us 50 miles per hour. Does that make sense for everyone? Yes, okay, that's good. And then the second one is kind of like thinking a little bit about what they give you and then converting it to units again. So let's take a look at the second one. The fastest trains are levitated above the rails to avoid friction. If you heard of them, they're called Maglev trains. They're pretty cool. So the fastest trains, they travel 155 miles in half an hour. So what is their actual average speed in miles per hour? This one's kind of like a thinking part. Oh, this class ends around, it might go over a little bit over 8. So I think this is the last question we will talk about today. Is number 12. Okay, so everyone got that right? I think. So we can actually do dimensional analysis to understand why. 100 miles in 0.5 hours. And then we multiply, we know that 1 full hour, sorry, I did this wrong. I am so sorry. So we know 150 miles, 55 miles were traveled in 1/2 an hour. So let's just call that an arbitrary unit. And then we're going to multiply that by, and we know that in 1 hour, there are 2 halves of an hour. So there's 2 halves. That's a kind of like an actual way to explain it. So we multiply 155 by 2, we get 310 miles per hour. So yeah, it's okay if I don't like dimensional analysis. Yeah, it's definitely slow. I show that for the purpose of, understanding truly when to multiply or divide, because I know I was confused about it when I was doing math counts in middle school. If you can do it in your head really fast, that's good. I feel like I'm just writing it out so everyone understands why I multiply by 2, etc. I know there's a more faster intuitive way to do it. So definitely, yeah, you don't have to do dimensional analysis. So yeah, that basically concludes. We're not going to go over the last 2. We have run out of time. So now that it's 8 p.m., we have, I'm going to share these worksheets in the Google Classroom, though, if you guys want to go through, work on them again and fill in the answers. I'm also going to share the Kahoot that we intended on doing today. Was pretty cool. Oh, well, we don't have time for it. I'm sorry. But yeah, I'm going to share that as an individual challenge that all of you guys can log on, and you can complete it whenever you want, but you're still technically competing against others in terms of speed. So if there's no more questions you guys can go ahead and exit the chat. So thank you guys for coming today.